This clip is going to look at the different processes that are happening within the Earth's crust around the world here. The diagram in front of you is showing the Earth's structure. In the centre here we've got the core, which is surrounded by the mantle, and then floating on the mantle is the Earth's surface, which we call the crust. And you know from a previous clip that the crust is broken, it's brittle and it's broken into a number of pieces, and those pieces are called tectonic plates. And the tectonic plates are floating on the mantle, so therefore they are moving. Some are moving together at the edge, some pieces are moving apart, and that will create different processes and different landforms at the edges, which we call the boundaries. The process of movement is all driven by what's happening in the mantle here. In the mantle you can see arrows, and those arrows are showing convection currents. So for instance, if we look here, we can see convection currents rising, which is basically magma rising. It hits the Earth's crust and it spreads. In this instance, it's moving towards, the convection currents are moving towards each other, which we call converging. Then they sink back down into the mantle where they're warmed again, and the process continues. If you look at the tectonic plates above, you can see that they're moving in the same direction. They are converging, which means coming together. In this example here, you've got the convection currents rising up, that's the magma rising up, hits the Earth crust, and it's spreading away, which we call diverging, and then sinking back down to the core. And again, the process repeats, which is actually moving the plates apart, creating that gap in the middle there. So that's two different types of boundary. There are other types on here as well. In this instance, they're also moving apart, only it's a different type of crust, which is why I've shaded it in green. This one here, they are moving together, and it's creating these mountain ranges. This one here, where am I? This one here, they're moving apart, again, creating features here. And we're back to this one when they're moving together. So we're looking at the different types of plate boundary, and that's what this clip will look at. There's a couple of things that are important that you need to know before we talk about the boundaries, and that is that the crust here, there are two different types of crust. On the diagram, the grey crust here is known as oceanic crust. Oceanic crust is made of basalt, and it's very heavy. It's very dense and it's very heavy. So although you can see that this is a thin piece of crust, it's heavy and it sinks into the mantle there. When it sinks into the mantle, it's destroyed. It's also created, just here, where we have magma rising up through this gap, cooling, solidifying and turning into rock, turning into oceanic crust. So it's being created and it's being destroyed. That means that the age of oceanic crust is actually quite young. In contrast, we've got continental crust here. Continental crust is much thicker, it's made of granite, and it's lighter. So even though it's thicker, it's lighter, and that's because granite is a lighter substance than basalt. Okay, it's also permanent. You can't see on this diagram that it subducts into the mantle. It does not go into the mantle, therefore it's never destroyed. It's also never created. So in that instance, it is permanent, whereas the oceanic crust isn't. So it's old, thick, light and permanent, whereas oceanic is thin, dense, heavy and young, because it's destroyed and created. Okay, we're going to now focus on this plate boundary here, which is where we've got continental crust converging towards oceanic crust. So they're coming together. What I suggest you do at this point is get yourself a piece of paper and draw the diagram with me. It's a good way of revising, and also you may be asked to draw a diagram in the exam, so it's good practice for you. Okay, so we'll start with drawing our oceanic crust. So here we have the oceanic crust. And I shall label that up, which you should do in the exam. And I'm going to put an arrow on it to show its direction of movement. It will going down into the mantle there. Then I'm going to put the continental crust on, like so, and label that continental. And again, it needs arrows. It's very important that you put arrows on your diagram, otherwise it's static and it's not moving and you'll lose marks. Okay, underneath the crust here we have the mantle, so I shall just label the mantle. And in the mantle there are convection currents. The convection currents must be moving in the same direction as the plates. Okay, so here it's going in that direction, sinking down to the core and rising back up. Here, this direction, sinking down to the core and rising back up. And you should probably label them. So convection currents. Okay, now to make things a little bit more visually pleasing, we will put an ocean on top of our oceanic crust, because generally speaking the oceanic crust does have an ocean above it, and this is our land, so we can just put some bit of green grass on it. There we are. Okay, so there's our diagram, and this is a destructive plate margin, so let's give it a title: destructive plate boundary. Sometimes known as convergent, because the plates are converging, they're coming together. Okay, and we've got the mantle here, so I'll just show that as red, as it's full of magma. So there's our basic diagram. Now there's a number of things happening in this diagram. We've got a number of processes happening. We're going to talk through those. We have a process of subduction. We have earthquakes that will form, or earthquakes that will occur. We've got mountains being built. And, so those are the processes, we have landforms. Landforms are things that you can see. They have been created on the land. They are significant features. So a volcano is a landform. Fold mountains, they are landforms. You can see them. And the other thing is oceanic or ocean trenches. Again, they're physical things that we can see, and that's what makes up landforms. Processes are things that are happening. Okay, so here's our diagram. The start point when we're explaining what's going on here is the convection currents. So the convection currents are moving together, and that's the first thing that you should talk about. They are converging, and this means that they are moving the plates above. So let's label that number 2 and number 2. So we have plates coming together. Now, when they meet, the oceanic crust is forced down into the mantle, and that's because it's denser and it's heavier. That's why it's forced down. Even though it's thinner, it is denser because it's made of basalt. So it is subducted. So point 3 here, it is being subducted into the mantle. The process is known as subduction, okay, and it's being subducted into the mantle. Now, this edge here between the oceanic crust and the continental crust is not smooth. It's jaggedy, because rocks are jagged, and there will be a lot of friction happening along that edge. And that friction will cause the plates to get stuck and pressure will build up. So pressure is going to be building up. So we've got friction here along this edge. Pressure is going to be building up until eventually the pressure will become too great and it will break. So the rock breaks. Let's say that the rock breaks just there. That point of break is known as the focus of the earthquake. So that's what the focus of the earthquake is. It is the rock breaking. And that is really what the earthquake is, because when the rock breaks, it sends out shock waves. A better word for you is seismic waves. And where those seismic waves reach the surface, just here, that point there is known as the epicenter. And it gets its name from the nearest place to the earthquake. Nearest place to the epicenter of the earthquake is where it gets its name from. If the break point, this focus, is deep, like it is in this diagram, the seismic waves have weakened by the time they reach the surface, so the shaking isn't so bad. If the focus point is shallow, like here, it's not got so far to go to the surface, and the shake will be far more intense, which will usually result in a worse earthquake. Okay, so we say the pressure builds up, and then we get the point of break, which is the focus. That concludes how earthquakes are made at this boundary, or formed at this boundary. The other thing we need to talk about are the mountains. These here. One or two of these might be volcano, but a lot of them aren't. They're just fold mountains. The way they have been created is because of the compressional forces of both of these plates coming together. It creates a lot of compression, and that's just made the mountains just buckle up there to create these folds. And that's why they're known as, the landforms that are made are known as fold mountains. Okay, a couple of other things to talk about are the landforms. So let's talk about volcanoes. There we go, let's put some magma in that in this part of the mountain, and we'll turn this into a volcano. Now I'll explain how this is formed. It starts in the same way. The convection currents move the plates together, point 2. Subduction still happens. The oceanic plate is subducted into the mantle. Now, when it goes into the mantle, it will melt. So this rock here is melting in the mantle because it's hot, and it turns back into liquid rock, which is magma. This magma, this newly created magma, is less dense. That means it's not as heavy. It's less dense because it's new, whereas the old magma in the mantle here is not as it's denser, so it's a bit heavier. This new magma that's less dense will rise because of the fact that it's less dense, and it will start to probe its way through cracks in the rock up into the mountainside, where it will start to pool and puddle, and it will keep seeping up there into the mountain, and the pressure will build up and up and up until eventually we have an eruption. These eruptions are going to be quite violent. They're not going to be very frequent, but they will be violent. And that's because this magma has had to come through quite a lot of a thick piece of crust, and it's gradually worked its way up under great pressure. And a lot of gas has built up in here. So this explosion, well, it will be an explosion, and it won't happen very often. So they're quite rare, and they're very explosive. And the magma that comes out is very sticky. So you'll get some magma coming out and coming down the edge of the mountain there, but it won't travel great distances because it's so sticky. You'll end up with explosive eruptions that will give layers of lava and layers of ash, and that's because it's explosive. So you end up with very tall volcanoes at this plate boundary, and that's how the volcanoes are formed. So a couple of extra points to add on to here for the volcano. Let's call this, we'll call this point so that we can carry on with our notes. Point 7 here. At point 7 we have melting. Then we have here at point 8 rising magma. So less dense magma rises. Then we have here pressure again until we get the eruption. And that explains the volcano. So in the exam, if you get asked to explain the volcano, you don't need to talk about the friction here and the pressure here and the earthquakes, because that's not what they're asking for. You need to just talk about convection currents moving the plates together, oceanic plate sinks down into the mantle, or subducts into the mantle, it melts, the less dense magma rises into the mountain, it pools until the pressure builds up, and then eventually it explodes. Okay, so that's the formation of the volcano. The last thing on this diagram, which is also a landform, we can see it, is the ocean trench. This deep part of the ocean here, very deep part, from there to there, is the ocean trench. The reason that's been created is because the two plates have come together, and as the oceanic plate has sunk down into the mantle, it has pulled the edge of the continental crust down to make this deep triangular shape, and that is the ocean trench. Okay, so those are the landforms we've got. Volcano, fold mountains, ocean trench. They are landforms, we can see them, they are physical features on the Earth's surface. And the processes, the movement, the things that are happening are subduction, mountain building and earthquakes.